Scientific notation is something you probably have already discussed before, but just to do a quick review of it, first thing we're going to do, we're going to place the decimal after the largest non-zero number. Rewrite the number, and then we're going to multiply it by 10 to the x. After we multiply it by 10 to the x, we're going to count the number of spaces you move the decimals. This number becomes your exponent, and the original number was less than 1. The exponent is going to be negative. So let's take a look at a few practice problems. So in this first number, our number is less than 1. Our first non-zero number is the 6. So we'll put a 6 with a decimal point. With that decimal point, we'll have the 5 times 10 to however many spaces it was moved. So we can count, we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's going to be to the negative 13th power because the number is less than 1. Grams is your unit here. So the abbreviation for grams is G. The next number, we're going to have 9.8. The largest number is 9. The key here is the number has to be between 1 and 9. The first number can be no larger than 9. So it's going to be 9.8 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9.8 times 10 to the 10th. It's a positive value here because it's larger than 1. The next number here, doing the same thing. It's going to be 1.04 times 10 to the 1, 2, 3, 4, negative 4th power. Notice how I'm including my units here as well. This is seconds. You want to make sure you're including your units along the way. For the next one, it's the 4 is the first number, so it's 4.07302 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 power PA, which stands for pascals. The next one, we have 4.38 times 10 to the negative 7th. We're doing the opposite. So we're going to do the opposite step. So we're going to write out our number, 438. Our exponent is negative, so that means we're going to move to the left. So we're going to move over 1, 2, 3, 4, 5, 6, 7. So any numbers that I have, I'm going to include zeros for those. So this is a very, very small number. The next one is a positive number, so it's 189. 189 to the 4th, so my decimal was here. I'm going to move it 1, 2, 3, 4 slots. So it's 18,900 liters for this number. And then the last ones that we're doing the same thing. We have 74. Our decimal was between the 7 and the 4. It's a negative exponent, so it's going to be moving this way. 1, 2, 3, 4. So it again ends up being a small number, and this is in grams. On quizzes and tests, writing your units in these sorts of problems is worth points, so you want to make sure that you do it, as well as clearly writing your exponents. There are SI units that are considered to be the standard units for measurement. We do use the metric system exclusively in chemistry, as in most sciences. You probably have seen some of these before. The ones that are a bit odd, mass, the base unit is a kilogram. So that's a common one that students struggle with. Decimeter cubed is the standard unit for volume. 1 decimeter cubed is equal to 1 liter. And that was intentional that it worked out that nicely. The other ones here, Hertz you've probably never heard of, and pascals for pressure. Pressure you should probably become familiar with. Notice it is a capital P and a lowercase a. There's a few formulas that we need to know for temperature. You'll notice it's in Kelvin. To get to Kelvin, what you need to do is take degrees Celsius plus 273. So that will get you to Kelvin, and then vice versa to get from Kelvin to Celsius. Density is equal to mass over volume for us. As it states up here, it's usually grams per centimeters cubed. That's another helpful unit to know. 1 centimeter cubed is equal to 1 milliliter, which is also equal to 1 cc. Cc is an abbreviation for cubic centimeter. It's often used in the medical field.